for joining for the excitement is much. Let's try to control ourselves such that we can have a very good lesson. We have two options. If you can't maintain silence, we remove you from the meeting. And if you were to talk anything in class, then you always put up the hand. There are only two options. You can't maintain silence in class, we wipe you out of the lesson. And if you want something, we always encourage you to put up the hand. I want to welcome you to this lesson once again. It's going to be lesson 2, mathematics, senior 2. We had started this lesson earlier on last week, same time, and we are here into something a little different than what we looked at last time. I'm trying to buy time such that someone making noise can keep quiet here before we remove them. And I want to work with some people here such that they help me remove some people cannot keep. Okay, I'm going to work with Ebo. Who else is here? Who knows what to do? I would give you Cynthia. I don't know if you've ever worked as a co-host, Cynthia. So we'll be adding more co-hosts as the need comes. I want to welcome you once again to this lesson. I want to request a volunteer to give us an opening prayer. We are going to start from where we ended last week, and we will get into deeper a little bit. Yes, Esther, you can give us the opening prayer.
Humble ourselves and we pray. Heavenly Father, King of Glory, I thank you for today's day. I thank you for the gift of a new day. I thank you for your protection and blessing us. Lord, as we're going to study this lesson, I pray that you enable us to understand whatever we are going to learn. Bless us and bless our teacher and bless the acts of our hands. In Jesus' mighty name I've prayed.
Amen. Thank you so much, Esther Agatha. And amen from this side. We'll always put amen in the chat such that we confess and believe in that prayer. You just type amen and you leave it in the chat there. So you're most welcome. And my name is Masawa Elisa. I teach math and ICT for the newcomers here. And I work with Mbali Secondary School and also the Holistic Learning Platform. And we always give lessons to students during this holiday. So I want to welcome you once again. I will pray that you maintain silence and we have a good time here. So briefly, I want to take you through what we expect this week from you students from the Holistic Learning Platform. What do we expect this week for our students at the Holistic Learning Platform? Esther, is that hand still up? Okay, it has gone down. So this is what we expect from the students of the Holistic Learning Platform in week 2. I'm going to display a timetable here for those who don't have the timetable. We are going to have math today, which is Monday, and it will go on from 2 to 4. And we'll also have the subjects you're seeing there. And what is important, on Tuesday, we shall have life skills and Kiswahili. I'm interested in the very last, this other side, which is baking. And it's a class that we've always had here for those who are not new. And we expect that you prepare for that day very well, such that we can have a very good audience and we can have people learn something. Now, baking is going to be so good, especially to those who have bought the ingredients. And if you don't do FN at your schools, which I know most of you here don't do FN, this is an opportunity for you to learn the basics. Actually, they will not be the basics, but the real thing of what a student who does baking is supposed to learn. I want to encourage you, dear students, to turn up on Friday. And I'm going to display the budget here. With that budget that was displayed in all our WhatsApp groups for baking. And that budget has a total of 21,700. I know this money is not that much if you're to invest in these items. Most of these items don't work only for one item. Don't only work for only once. You can keep them and keep using them over and over. I want to encourage you to buy the items displayed here. A long detailed messages in our WhatsApp groups. I encourage you to go back there and read about the baking class. I'm telling you this on Monday and the class is going to be on Friday. So you ideally have about 4 days to plan for this well. If there are any questions, please post the questions or any inquiries on the WhatsApp platform such that you are answered before Friday. This is going to be another exciting one. Yes?
Teacher, could you please tell us the WhatsApp number?
The WhatsApp group, probably it's what I can give.
Yes, the number.
Not the number, the WhatsApp group. I'm going to share it here such that you can tap on it and join the WhatsApp group.
Okay, teacher.
I'm going to display it here. I'm trying to look for it. But these are classes you need to attend. I'm trying to look for this link. If anyone gets that link faster than me, kindly post it in the chat for those who are not on the platform to also not miss any information. I've got it and I'm going to post it. That is the WhatsApp group. It is senior to B WhatsApp group. Make sure you join. All our other groups are full. So if you delay and you don't join this one, you may find when it is full as well, and you'll be closed out. I want to encourage you to turn up for this. Buy a few things here. If you can't find them today, buy tomorrow, like that until Friday. These cakes you're going to learn, you may even carry them to school. Like maybe instead of making the traditional G-nuts that we always fly, or maybe the hard knocks. You can think about this new. And when they ask you, you say, I got the skills from the holistic learning platform. So that one is done. And we are going to proceed with our lesson of mathematics, and specifically today, under indices, we are going to concentrate on approximating answers when you're dealing with calculations. So at that juncture, I want to welcome you once again to math. For those who are just coming in, you may be wondering. Now let's not go to WhatsApp and talk from there. I probably needed to close that WhatsApp. Let me do that. Let's not go there to chat from there. I have to close this for a while. I will open it. For those who have not posted their work, I will open it later on. But for now, we have to all be here. I encourage you to join, but don't chat from there. So we have been talking about indices, and we saw the properties, the major rules of indices. Like I told you at the Holistic Learning Platform, we give you a hint in what you're going to learn in the coming week, or we revise with you what you studied. So I have given you a hint in the principles of indices. When the bases are the same, add the power. When you're dividing, do this. So that hint, I believe, is enough. And we are going to talk about a relatively different thing than the one we talked about last time. And today we are going to concentrate on approximating numbers. Eric, 10. Eric, what is that? Your hand is up.
Sir,
So, okay, like the previous activity, there's a number you gave us, and in the explanation, I have that any number raised to power half is the square root of that number. So do I just write 7 if the square root is 7?
If the square root is 7, but you don't just straight away write 7. You should be disciplined enough to write that number to power 2. I think it is 7 to power 2. It should be 49 under root. So you write, you factorize 49, then you'll get 7 to power 2. Then you power their half. Then those two will cancel out to give you answer as 7. Don't just write 7. It will show that you have got it from the calculator.
Okay, sir.
So I want to encourage you to do those activities. We ideally don't have a lot of time with you during the holiday. So we can't learn one thing over and over. We give you hints, and if you have time, you go and dig deeper. That's why we have only one lesson in the afternoon, or two, but still in the afternoon. You have the whole day to look at what you've learned and apply. And for us, we're always online to keep guiding you here and there. So you write to us in our inbox, or if the WhatsApp group is open, you write straight away to the WhatsApp, and even your friends can help you. So in today's lesson, we are going to approximate answers. I will expect you, and it's a must for you to have a calculator this afternoon. If you don't have it near there, can you pick it such that it is so close to you? We may have a question like, they are dividing 13 by maybe 5. Michelle, don't write there. They're dividing 13 by 5. These are normal divisions. But when you divide, what is the answer you get? Someone can put for us that in the calculator. 13 divided by 5. Davinia, hope you're writing the right answer. 2.6. 2.6. Yes, someone has 2.6. Correct. 2.6, when you divide 13 by that, what if you divided 7 by 15, for example? 7 by 15. Yes, Leah, your hand is up. May I know? Leah, your hand is up. Okay. 7 divided by 15. I want someone to write to tell me that answer. 7 divided by, yes, someone has 0.466. Another one has so many sixes. Another one has, let's not write. Let's not write. Maybe for now, let me close even writing. These are very hardworking students. They will darten the whole screen. Another one has 0.466.
Teacher, I got my answer as 0.46 recurring.
0.46 recurring. What is recurring? 46 or 6 alone?
It's 6 alone, which is recurring.
So we show that it is 6, the one that is recurring. And some people have 0.466 up to. Another one has put 7 somewhere there. This person who has put 7 has taken my attention. Is called Priska. And we have Ebo. Ebo has also 7 somewhere. And the rest also have, some have 0.4. Yes, please. Then another one has a solid answer, 6. That is Daniela Nakanyike, 6. I don't know whether that was a mistake. So, peace, we can go on. Peace, your hand is up. Okay, Peace seems to have not known maybe what she had done. You can't put up the hand and you forget it there. Peace, may I know? If you're talking, then we are not here with you. Or else I'm going to lower your hand such that you don't maybe struggle to put it down. I've lowered that hand, Peace, just in case you realize you had a question to ask, you put it up again. So we were trying to approximate those values. And you have seen that many of these questions, Peace, you can go on.
I had got 0.46 recurring.
0.46 recurring. Actually, 46 recurring, a person already has that, which is correct as well. So all these answers, maybe they are wrong, maybe they are correct. What do you think? They're not looking the same. Are they wrong? Are they correct? Or what can you say about the answers? The question is only one, and people have so many answers. Elvis now has a new answer, 0.5. And 0.5 means this is a half. Can this really give us a half? Elvis has a new number. He's telling us the whole of this is the same as a half. So, are we wrong? Are we right? Can someone put up the hand and try to bail us out? Because we cannot have just one number being divided, and we have about 7 answers here. I know if given chance, many people will have, and the same 0.467. Another totally different answer from what everyone has here. Then another one, KZ, has 0.466 recurring. Are these wrong answers? Are they correct? Yes, Eric? Eric, is that your name?
Yeah.
Okay.
So I think that that person with 0.5, like, should I say, like, approximated the thing?
To 0.5 like has approximated.
Yeah, but even though you approximate, it doesn't give you 0.5.
Yes, but I don't want you to critique someone's answer. I want you to give me a general conclusion. Are these answers correct or wrong?
I think he carried, like, he.
No, don't base on one person's answer. There are so many answers scattered there. Are these answers correct or wrong? Because one question cannot have many answers. I think you were saying something. Okay, can we get the next person as she prepares to come back? Are these answers correct? Yes, Esther, you can go on again.
In my opinion, I think the answers are correct, but different people are rounding off to different significant figures.
To different significant figures. There is now a new term, significant figures. Hope your intention was not to confuse us. Significant figures means what? Higher, Esther's gone. But then, at least I've had one new term there, rounding off. Maybe people are rounding off. And I want to develop the concept from there. When you're given a question, and maybe because of space and what, maybe, we have to estimate the values. Every time you're given work, and in real life, for example, you're traveling in a car, and me, I sometimes travel from Bali to Kampala, and if it is express and there is no jam, that is about 3-hour drive. When you use the formula for speed, and time and distance, because from Bali to Kampala is just 200 kilometers. So if you're driving at a speed of 60 kilometers per hour, maybe someone can give us the time you spend in a car to reach Kampala from Bali. The distance is 200 kilometers and the time is around, the speed most buses use is around 60, 70 kilometers per hour, like that. So as a mathematician, you might need to know, for me to leave Bali to Kampala, I'll need how much time. You may not have the exact track space physical qualities. Jocelyn has something in the chat, which we'll get back to. So you realize as a mathematician, you can't just start to walk from here to Kampala when you've not calculated the real time, but you can never have the correct time. So all of these answers on this screen here are not the accurate answers to that question 7/15. You will find out no answer here is accurate. But these are approximated numbers. Now, your calculators must be showing you 4.6666, and because your calculator cannot display any other figure, but when I put that on this laptop, it will display so many sixes because my laptop, the screen is bigger. Now, if you went to a bigger screen, then you will even see more digits. So all of us here have just approximated these values. And when you approximate a value, it doesn't mean it is a wrong value, but it is a value that is close to right. From Bali to Kampala, it's 200 kilometers, and the distance, we expect the speed to be around 60 kilometers per hour. Which time is required for you to reach Kampala from Bali? I want to see a person with that answer. Distance, 200 kilometers. The speed is about 60 kilometers per hour. I'll wait to read about that in the chat here. But you realize that that answer you're going to get is approximated, because while you're traveling in the bus, it may need you to stop somewhere. That time you didn't plan for it in your calculation. Maybe traffic jam at some point. So for you, you'll get the answer that is not correct. That is not the exact value, but it is the answer that is roughly close to the right answer. So I want to introduce you to approximation of answers whenever we are dealing with calculations. And I had given earlier on some activity in the chat, 3.5 hours, 3.3 hours. Someone has 3 hours, 3 hours. Now 3.3 from Elvis. Shannon has 3.5 hours. So it depends on how you're calculating, but all these are approximated values. Now there is this able with 3 hours. You will sit in that car and you may reach Kampala after 4 hours or 5. So all those answers are approximated values. So when we talk about approximation of values in mathematics, it is a very big concept students must understand. But now, when you're approximating values, you must be very sensitive to how many decimal points. And later on, we'll talk about the decimal points. So the approximation of values is something you may not avoid. So when we are approximating values, I gave you an activity in the morning for those who read quickly on the WhatsApp groups. I am also informed that some students can't access phones maybe in the morning, but sometimes always request your parents to check and see what is on the platform. In most cases, for math lessons, there is always that activity that comes earlier for you to appreciate the lesson. Otherwise, if you come when you've not done the activity, then you may not even know what we are talking about here. I gave this activity and I requested that you look for anything round around your home. Then you get a piece of thread and a ruler to approximate. Actually, I wanted you to approximate, not getting the right answers, because I know even if you concentrated how you can never get the correct answer when you're measuring. Measurements, in most cases, the values are approximated. Maybe if you're using a standardized device, like a tape measure, and maybe we now have digital, for those who now shop from supermarkets, there are those weighing scales that are digital. But all these other devices that are available, all these gadgets, the rulers we have errors. And when you get to A level, you'll appreciate, they will tell you a ruler has this error, a tape measure has this error, and you'll even calculate those errors. So I requested that you get me those answers. Maybe to the best of your knowledge, you thought you were getting the correct answers, but those were approximated. Even the value that I put here, my sugar barrel here, it looked big, like as if the circumference would get to 45 centimeters. But I was surprised when it was on the ruler showing me 33.5, close to 34, and me I expected around 45. And because of that, I wrote what the ruler gave me, and its radius, sorry, not the radius, the diameter. I forgot to remove that. The diameter is, hope you didn't write that as radius. The diameter is 13.8, and the diameter is the distance from the circumference to this other side of the circumference, but through the center. So I got this 43.5 and 13.8. And when I divided, I got 13.15. All these are approximated values. I want to show you some of what the students managed to come up with. And these are approximated values. We had Shannon, if that is how they pronounce that name. She gave us 3 items here with the ruler, with a piece of thread, you can see it there. And she told us she was going to measure this, and this is her table. The table is here. The first item is a glass, 25 centimeters, the circumference, and her diameter was 7.8. All these are approximated values. I wonder how she got 25 straight away. Chances are so high that it could be 24.8 point something, but she chose 25 because she needed to approximate it to the right answer she thought was correct. So this cannot be accurate, it cannot be exact, but it is an answer that is approximated. And when she divided, she got her circumference divided by the diameter as 3.1.21. Now, the actual answer when you divide for any circle, let's note this, for any circle that you divide, once you get the circumference over the diameter, the answer must be pi. When you divide your circumference with the diameter, the answer must be pi, and pi is the same as 3.14 approximated. If you don't want to approximate, then it is 22/7. That is the most accurate circle the whole world has ever seen. Its circumference is 22 and the diameter is 7. That's why it gives us 3.14. That is the most accurate, the most correct circle the whole world has ever seen. The circumference is 22/7. When you look at Shannon's work, it is actually the slide plate, the slide plate over that one. Which one? That number 2. She correctly got that. I'm not sure if she measured or she got it from the book, but it is only that value that was close to the standard circle. If she measured it, then that was too perfect. Then the first one and second one, I think the first glass was too close when you compare it to the barrel. So you can see that she approximated, but still she was in the range of 3.14. You realize that that range was still correct. So the standard circle is 22 over 7, and the circumference is 22, and the diameter is 7. So when you put it in the calculator, it is approximated to 3.14. And I would correctly mark this as correct. She approximated this well. Even this was approximated well, even that was approximated well. She needs to just go back and approximate it well such that it doesn't go to 3.2. Maybe the problem was the thread she was using. So that is Shannon. And that was a good display that I saw in the WhatsApp group. Then we had another person, Hannah. This was Shannon, and that was her work. Then the next one is Hannah, and Hannah tried so much, and she was using these items you can see. There is this black one, looks like the one for shoe polish. Then this one, I'm not understanding, but this one looks like for curry powder. Anna, can you explain your shapes you have here, these items? If you're on.
The yellow one is a glass. The black, yes, is a shoe polish tin. Yeah. Then the black one is a shoe. It's a tumbler, okay.
Then the next one is for polish.
Shoe polish. Then the next, that one had in about curry powder. It had in curry powder. It got done. Then the next one right next to it is a small bottle for orange essence. Then the other one is chocolate powder.
Oh, so she has these ones. Let's see how she got her answers. And at the look of these shapes, I think it's only this that can bring out the real shape of the circle. This one is not so close. Maybe this one and that, but this is also not very close. Maybe the top, but how would you estimate this top? Provided we see 3 point something in her answers, then she'll be close to the right answers. And this is what she gave us. And there is 3.7, a little bit close. 3.8 still close, but far a little. And you realize that this orange, this number 3 is 4. It's a bit far away from the correct answer. She's trying to approximate these values, and I'll tick all of these values apart from this number 3, which is 4 straight away. At least the range is correct, but I think she was using a wrong thread. You can see the thread she was using, maybe disturbed, and even the nature of maybe the shapes she was using. That's why she didn't come up with 3.14. So Hannah, this one, I would also qualify it apart from that 4 centimeters that I would doubt a circle to be 4 centimeters pi. Its pi can never go to 4. It is around 3.14. Maybe you add or reduce 0.1 to that for errors. Then we had another student. This is Tracy. Tracy also, I think, was considering about 3 items. I am wondering, I don't know if Tracy is here, should explain what she gave us here. Tracy, are you on? This is called Tracy. Tracy who? Nanonzi. And she gave us this 1, 2, 3, 4, 5. This thing looks familiar, like the one for what Hannah gave us, and it gave a good answer for Anna. Unfortunately, Tracy's work was a little faint. I was unable to see and try to see if she maybe approximated well or not. Tracy, are you on? You help us explain this, or we can just proceed. Yeah, I think Tracy, are you on? Okay, I think she's not on, but at least she has some shapes that she was using. And if she gets on, she needs to give us a good picture of her table such that we are able to read. And you realize that it is very good for us to learn approximation of values, because then it helps us to approximate. I want to get back to our activity and we try to answer and see how we approximate the values. For example, who can give us an item you approximate for us here? If you have it in your book such that we fill it here for you, put up your hand if you did, but you've not seen your work and you want to give us one of the items. Tracy, are you now ready? Okay, if you're not ready, Tracy, close it from this side. So these values are approximated, and that is what I wanted us to appreciate when it came to that activity. And when I gave you 7 over, was it 13? Someone remind me this. Was it out of 13?
15.
15, 7 out of 15. Many people got 0.4666, and someone was putting here 7. Another one got 0.46 like that. Another one got 0.5 like this. These are called, this is rounding off. And in rounding off, there is a term called round up and round off. We are going to see what that means. Maybe it's a new term. So every time you're rounding off a number, you're estimating it. And the smaller the decimal places you have approximated it, the more errors it has. I would cross 0.5. I would not spare this. I would cross that because you have reduced your answer to almost 1 decimal point. This one is to how many decimal points? 1, 2, 3. This is to 6 decimal points. 6. This one is to 2 decimal point. And this is 1 decimal point. I would not take the last one. You can't be that bad to approximate the whole of value to 1 decimal point, unless if the question has requested you to do that. If they have not requested you to do that, what if it is 0.47? That is to 2 decimal place, and I would maybe sympathize with that. And this person who gave this 0.6 is wrong as well. You have not approximated this value to 2 decimal places, because the correct answer is supposed to be 0.47. They have rounded it up to 7. The 6 has been rounded up to 7 because the 6 is above. We are chopping off from here. Let me use a red, a yellow, a green color, or blue. They are chopping off from here to give us 2 decimal places. So when you're chopping off from here, you check behind here. Is the value that you're throwing away, is the next value that you're throwing away the immediate value above 5 or less than 5? If it's above 5, we round upwards. We don't chop off and leave it. That's why the correct answer is supposed to be 0.47. We have rounded it up from 6 to 7. And rounding off and to decimal places, it is another full topic, but here we just give you a hint. Now, this table you're seeing here, I request you to go and approximate these values, and your answer, like mine was not close as well, 1.45, 3.14, I mean 3.15, but it was fair because at least me, I knew what I was looking for. But because for you didn't know what you're looking for, it was hard for you to get the correct one. What if I get C divided by D with recurring digits as 12.34? Now 12.34, this is a wrong circle. Isaac, you measure that again. This one is a wrong circle. It is totally not correct. It can't be 12. It has to be 3. Your answer must be 3. But I will answer your question. If it is recurring, you still chop off. You round off if the next value is above 5. For example, this one can be rounded off as 12.335, like that, to 2 decimal places. I'll put it in the chat. The answer you get there. If you want to round off to 2 decimal places, then it is written like that. So I was trying to prepare you for rounding off, and we want to talk about rounding off to decimal places. And the chapter here, they have specified and they have said students must be able to work with decimal places. And I'm going to move too fast here because of time. I'm going to display this, and I will assume you're able to read. I'll just talk about this, rounding up and rounding down. If the next value that you want to throw is 5 and above, you round up. If it is 5 and below, you round down. And round down is meaning you just discard the whole of it. So this particular one was rounded off to 2 decimal places. You can see that initially it was this. You can see this is the number. This is the number, but it has been rounded off to 2 decimal places. So you chop off the remaining, but you check the next value. If it's above 5, drop 1 this other side. If it's below, then just discard the other one. For example, if I put for you here, and you're going to put this in the chat, can we write? Now here we don't make notes. We don't make notes here. You just choose to write what you think it's important. You need to have a book, but there is nothing you're supposed to write here. You just listen and understand, walk out of the class. If you feel you may forget, then you must make simple notes. That is what I expect you to do. And most people who are now familiar to these lessons have books and they write simple notes to help them remember. So, for example, I have 5. Let me put 5. I'm going to put, I want you to round off for me this. I'm going to put it here. I want you to round it off for me. It is 5.34611 to 2 decimal places. This one will be 2 decimal places. You give me this answer to 2 decimal places. Then the third person can give me to 3 decimal places. If you're given that number to 2 decimal places, it will be what? And to 3 decimal places, it will be what? Joyce, you can go on. Joyce, give us the first one.
So I can't see the screen.
Oh, sorry, then I don't know, but your friends are able to see. Maybe you log out and come back again.
What's the answer?
Yes, Amal Mohoez, what is your answer?
Teacher, the answer I got is 5.3. The answer I got is 5.34611 is approximately to 5.35.
To 2 decimal places. Okay, yes. Thank you. Can I get the next person to give us Elvis to 3 decimal places? It will be what? Elvis?
Yes, thank you, sir. 5.34611 to 3 decimal places, it will be 5.346.
4, 6, like that.
Yes, sir.
Can we probably get a person to mark for us this? Just put up the hand. I'll open the screen for you to annotate. Let's first lower all these hands for now, such that you only put up the hand if you can manage to annotate. I'm going to lower all the hands. Okay. If you can manage to annotate and mark, put up your hand. I will give you a chance to do that. And you mark using a red color. Yes, the rest have been participating. Davinia, you can go on. I'm going to open here. Pick a red color and mark for us. If it's wrong, you tell us the reason. And if it's correct, you tell us the reason. And Davinia, you can go on. Davinia, where have you started from? Hey, Joseph is starting to mark from this side without permission. And Joseph will remove you. Davinia, you can go on. Where are you marking from? I want you to mark.
I can't see the screen of the work.
I beg your pardon?
I can't see the screen of the work.
Sorry. Maybe we'll have to give you time. Let's get Eric. Eric, you can go on. Davinia, maybe you move out of the meeting, then come back immediately for you to see the screen. Eric, you can go on. Are they correct? Why are you not talking to us? Why are you ticking them?
Yes, sir. They are correct.
Just like that?
That's awesome. Like 5.3461 to two decimal places. We round off the 6. And 6 is more than 5, so we add 1. We round up, we add 1, and we get 5.35 to 2 decimal places. Then 5.34611 to 3 decimal places. We are going to round off the 1 to 6, but 1 is less than 5, so we round down and we add 0, so we shall get 5.346.
Okay. Now, there is that person using Infinix. You better excuse us if you think this is fashion show or something. This is a lesson. We will not spare you. We'll take you out of the lesson. I have very strong team here. My co-host, if Infinix, what was that? Infinix or iPhone? I didn't see that phone. If you repeat to write again your colors here over hello, we'll remove you. We don't care. So she has told us that we can round up and round down. Round up for 1, rounding down we add a 0. And I don't want to add a lot here. I will assume that was correct. And the next example is this one here. You have been given 68.157, 68. Actually, this is read as 68. It is this other side that you read one at a time. This is 68.1572. They want you to round this off to 2 decimal places and to 3 decimal places. And to 2 decimal places, it is here. To 2 decimal places, it is here. And no one should now ask me why we have 6 here, because Eric had tried to explain that if it's above 5, then we get 1 and add to this. If it's below that, we then get and put to this. Now, we are rounding this. If they asked you to round it to a whole number, then you chop off from here. Are you seeing? You chop off from here. And you check this side. Are you rounding up or low? If you're rounding up, you add 1 to make this 69. If you're rounding down, then you just add 0 to this to give you 68. That's why we see 68 here. And this is to 2 decimal places. This is to 1 decimal place. 1 decimal place means we chop off from 1 decimal place means we chop off from 1 decimal place means we chop off from here like that. And because there is a 5 here, that's why we have a 2. And I'm waiting to see the answer to 3 decimal places. If they asked you to round that off to 3 decimal places, what would be your answer? Can I have the answers here? Well, people have started using the chat. I didn't know answers were here. Ebo has the answer as 5.3. Are these answers? I think these are all the answers. The first answer is from Mukisa, and he has got 68.157. Yes. Yes, everyone has 68.157. Well, that is what we expect. Anna has given us as well. Regina has given us as well. Jaydin, Jemima. Then there is Neymar Jr. I don't know if that is a name. And we're going to start removing people with nicknames here. Sabrina, correct. Eric Tang, that is correct. Techno Common 15, correct as well. And Esther Agatha was among the first people here, correct as well. Shannon, correct. Mukisa, and another person here with a nickname. Kama is correct. Daniela is correct. And Jennifer Priscilla Owere. Owere, yes, that is also correct. And Elijah has the correct answer here as well. So for now, rounding off is covered. If you've not written anything down, take a screenshot. You look at this and see what to write. The last one is here. If they wanted you to round that to 2 decimal places, the answer will be 8.74. Leah, your hand is up. Leah, you can go on. I'm going to put a very hard question here for people to round off, because I see people seem to be bragging here that they have mastered how to round off. I'm going to put a very complex one here. I want you to quickly round off here for me. And the first question is 72.366954, like this. I want you to round off this big value to 4 decimal places. 4 decimal places. The second question is here. 0.00615. 15, like this, to 2 decimal places. I'm waiting for those answers. Just in case you don't fear your answers, you put up the hand and give us these answers. Elvis's hand is already up. I can't hesitate to give you a chance.
Yes. Thank you, sir. The first answer is the answer to 72.366954 to the nearest 4 decimal places is 72.3670.
First, wait, I want to add more space here. The answer is what?
72.3670. 0.3670.
70. Okay,
Yes,
he has 70, and yeah, that one brings a very serious discussion now. Someone is challenging your answer. I see the hand is up. Anyone challenging this answer? Peace, do you want to challenge his answer? Peace, what do you have? Peace, what do you have? Peace, I don't want a person with the hand up and you can't speak. Davina, that is how they pronounce your name. Leah has not been speaking since. Davina?
Yes, teacher. I got 72.3669.
70 what?
72.3669.
669, like that.
Seven.
Okay. I think this is what you have. Is that what you have?
Yes.
Okay. Leah, what do you have? Leah, I don't know, but you're not speaking. Maybe this is the last time I'm recognizing your hand. I will not give it a lot of attention. So, I see people have, Leah, I'm trying to lower your hand down. You're putting it up and you're not speaking. The next time you put it up and you're not speaking, that will be indiscipline, and I will request that you excuse us by taking you to the waiting room. So, this one, I was seeing so many answers in the chat. I don't know. Bridget has what is on the screen. Let me see. Jennifer Priscilla has a different answer here. Jennifer has this 7, 2, 3, 3, 6, 7, like that. Now, let's debate about what Jennifer has and what these three people have. For the first one, maybe if I'm the one marking, Davinia, this is wrong. I don't want to discourage you, but I think you did not master here well. We are chopping off from here. This is 5. It is bigger than, it is 5, and it is, maybe I did not explain that well. It is either 5 or more than 5. 5 or more than 5. You round up. If it is not 5 or less, we round down. So for that, Davinia, you didn't master that well. Because there is a 5 there, we have to get 1 and put on 9 to make it. That's why your friends have 7 here. This became 10, and you can't write 10 here, but you get the 1 and put here. And this one is correct. I would not correct this for Priscilla. This one is not good because you cannot be requested to write a value to 4 decimal places. For you have written it to 3 decimal places. That's why that 0 is supposed to be there. So I don't know whether Florence has seen that. I can't see the screen that is on your end. People here can see the screen. Then the next one, who is reading for us the answer for that? I see the answer is flooded all over in the chat, but someone can tell us this. Patricia, for the first time.
Okay, sir, I got 0.01.
0.01, like that. Is that what you have, Patricia?
Yes.
And this is correct. That is correct. Whoever has that, it is correct. So I want to encourage you to give rounding off a lot of time. I want to give you chance. I want to encourage you to give rounding off a lot of time. If you can't round off a number in senior 2, I want to request you not to be happy. Don't be fine. Not until you manage to round off numbers. It is from there that you can be happy. Otherwise, that will be a very bad thing. In senior 2, you can't round off. So I felt I needed to remind you how they round off, and I'm covering this. We are entering into a very serious thing, and that serious thing you may need to concentrate even more than this. Can I get any question, if there is any question here, before I wipe off this? And the question does not mean that you've not understood. Even saying, me, I've understood that, you'd have at least said something. You don't have to keep quiet here.
Teacher?
Yes.
So is it wrong if on number 2 you do 0.010?
0. If you did 0.010, you would have written this to 3 decimal places, and this is wrong. Don't do that. I'll tell you later on what that means.
Okay,
But
thank you, teacher.
Don't do that. We always round off. Now let me tell you something. We always round off because we want marks. Like if it is in physics, they have given you a table of values. They want you to do that to get marks. Everyone is here for marks. 2, sometimes the space of that area where you're going to fill the answers is limited. So the examiner specifies that only write 2 decimal places. I want to challenge you that one, if you use the wrong handwriting, it may not fit here. That is 2. 3, rounding off in most cases is used in programming. Something in ICT you may not understand, but these 2 are different answers. When it comes to significant figures, you get to know what that means later on. Eric, your hand is up.
Okay, so like me, yes, I got 72.3670, but like I just got it from my head and I said, since there is 9 and I'm getting 10, let me add 1 to 6, and I just put the 0. So like really, like, should I say I added the 1 to the whole number 6? Okay, 69. Then I just put 70. But I don't know how it comes about.
70.
Yeah, like why do we put 70?
Oh, sorry. Who can help the girl understand that? I thought that was a bit obvious. Someone put up the hand and explained that. Why is it 70? I think ideally for you wanted to write, oh, sorry. I think you wanted to write 72.3610. Did you want to write 10?
No, like me, when I got the thing, when I added 1 to 9, it gives me 10. So since like it's 3669 and it's 69 and I'm adding 1, I just decided to make it 70.
No, it was not 69. It was 69. They read it as 69. That is not 69. I never read it as 69.
Yeah, so I know. Okay, like I know it's 69, but
so 69 cannot be 70. Like it cannot just be that. Something to do with place values. Let me get a mathematician here to explain for us here. Vivian.
Chamia was saying, since 9 is more than 5, it means she had to add. Since 5 is in the more than, she had to round up 1. Then after getting that 1, it makes 9 plus that 1, it becomes 10. But we cannot write 10, we write 0.
We cannot write 10, we write 0. So you're trying to suggest that it becomes 6. We don't write 10 here, but we write 0. Is that what you want to suggest? Vivian, did you go off?
Since 9 is more than 5,
yes,
we
that
carry
one.
a 1 and add it to 6, and then it becomes 7.
No, we are
and
rounding
then
off. Yeah. Wait. We're rounding off from here. It is 5, not 9. It is the 5 that is adding 1 to 9 to make it 10.
Yes.
Why do we write 7 instead of 10 here? It is something to do with the place values. At least you have a good idea. We can't write 10 there, but you have failed to let us know why we write 7. Maybe you think about it again. Patricia, give us a try.
Okay, sir. I think when the 5 was rounded up, when this number was rounded up, then the 5, of course, it's in the more. Okay, it's more. Then 1 was good. When you add 1 plus 9, that is 10. So you put that 0 and regroup 1. You can't write just 10 there. I think, yeah. Just regroup the 1. Then when you add that 1 plus the 6, it's the 7.
It's the 7. So you write 0 and carry. I don't know whether you're hearing to speak the primary mathematics, but you're not bringing in well. There was that mathematics of primary where they said you carry 1. Carry 1?
Yes, like you carry 1.
I bring out the mathematics of primary. Don't just throw it. It is the one that is carried on to 6 to make it what? 7. That is it. So we may not take the old. Elvis, you want to spice it up? Thank you. That was who? That was who? Mind me. Anyway, that one has gone. Elvis, what do you have to say?
Yes, sir. Okay, like the way the work is there, a person may not understand very well, but it is as you have said, that is lower primary. Like I want that person to get maybe a pen and do this addition. Like if it is, we have said that to the nearest.
Do it from here.
To the nearest 4 decimal places. So we say that we are going to chop from what? From what? From 9, not so? Is 7, 2, 3, 6, 6, and 9, 5, 4. Then we say that we are going to chop from 9.
From 9
okay,
here.
In between 9 and 5.
Around here, we are chopping off from here.
Yes. So we said that 5, it is when it is 5 and up, we round up, adding 1 to the required what? Decimal place. So I would like you to put that addition sign down there, then you put 0.0001 in order for that person to understand it clearly. 0,
1,
0, 0, 0, 1.
I put 1.
Yeah.
Probably.
Then when you add mathematically, there it will be 10. So we write 0.
Okay, hold on. I want to rewrite it. It is 7, 2, 3,
6,
9. And we
5,
are adding.
And we're adding 0.0001.
Hey.
Yep. Thank you.
So this becomes 10. We write 0 and we
0.
Yeah, correct. Now this one explains it well. I think Elvis, this one is far, far better. People were fearing to mention the primary mathematics. I think this can now help you speak like a secondary student. So basically that is it. And it has to be 7. Davinia, I don't know if you're still on. Did you see that? I don't know if she's still here. Well, that is it. And we will not take the whole day here. Can I know if there is any other challenge? Put up your hand, mention it, and we proceed. Because what we are going in for is what we need most than even decimal places here. If there is no hand, we can proceed. I want to know. Okay. No hand here. We'll proceed. So this was working with decimal places. And in the next slide, I really don't know if time will be enough, but we are going to work with significant figures. And when it comes to significant figures, you need to be very, very attentive. I really don't know how can I tell that people are attentive here to listen to significant figures. Maybe I will request that we get a break a little, you stretch a little bit. You can, I don't know what you can do. On Zoom, I don't know if there is anything we can do like icebreaker. We can't sing a song here, but just get a pen and try to write any mathematical statement on the screen that is true. I will be able to read it. I'm going to start by myself. I'm going to write a mathematical statement that is true here. 2 + 1 gives me 3. This is a mathematical statement that is true. Pick a pen and write something. This is Davina writing 41 + 1 gives us what? 42, correct? Eric was trying to write something. You can go on and write. Can we have as many people writing as possible at the same time? Esther Agatha is starting something. Priska is starting something, though not yet. Jojo, Scott's done. Bridget has 9. 9 + 1 to give you 10. That Bridget, that was too young. 2 + 1 to give you Jennifer. Then we have Sabrina. Afro Jojo is writing something. Scott Dans, we've not yet got. Ebo is writing what here? Anyway, change the colors such that it is visible. 6 + 93. Who was writing that? 6 + 93. And then 49. Eric Tang is writing 49 + 1 gives you 50. That is correct. Faith Hilda is writing what here? Then Shannon. Anyway, now the screen is too black. I can't see. I'm going to clean it once more such that you write very fast and yours comes correct. Who is writing? Regina 2. Now, how do I read here? Jennifer, Priska, Howell, Eric, Sabrina. Now this is totally messed up. I can't now read anything here. Okay, let's not now. We can now maybe stop such that we don't write again. And probably that one can help someone stretch a little bit. If you manage to write, it is a bit hard. If you can concentrate and write, it is almost like a jump. So I want to welcome you to significant figures. Now, dear students, significant figures, you people, significant figures, if you cannot master them, you're going to have a lot of problems when you go back to school. Significant figures, make sure. For significant figures, make sure you listen very carefully to what I'm going to talk about here. If you have not come back, you better come back, get a glass of water, take and sit and listen. Otherwise, if you don't listen to this, it is going to confuse you properly when you go back to school. When I write 2, 614, like this. This number has been written to 3 significant figures. But actually in decimal places, if I'm to verse it with decimal places, this one has been written to 1 decimal place, actually to 0 decimal place. I can write another number like this, 3, 1.5, 1.50, like this. This one has been written to 4 significant figures. This one has been written to 4 significant figures. And yet to decimal places, these are just 2 compared to 2 decimal places. You see, for decimal places, there are just 2 here. But for significant figures, there are 4 of them. Now, I want to write for you another complex one. Maybe 2. Allow me write it down because space here is becoming small. 2, 1.000051, like this. How many decimal places are these? Someone put up the hand and tell me to how many decimal places has this been written? This is what we've been looking at previously. This is who? Bridget. How many decimal places are here?
Yes. There are 4. I mean 5.
There are 5 decimal places, correct? 5 decimal places, because this is 1, 2, 3, 4, 5. And for significant figures, surprisingly here, significant figures, they are only 4. They're actually 4 significant figures. This is even a fair example. But if I wrote to you this, like 0.0007, like this. And for decimal places, someone tell us this. Decimal places, how many are they here? Decimal places, Eric?
4 decimal places.
Decimal places for DP. Who can guess the number of significant figures here?
1.
1.
That was who? I wanted to see the name. This is to 1 significant figure. Okay. What if I added? Now I want to see. I want to trick and see if people are seeing here what I'm doing. What if I added that? Put up your hand if you're sure of the mathematics here and answer those questions. How many decimal places? How many significant figures? I'm going to write decimal places here. Let me see. Faith, you can tell us how many decimal places?
6.
Faith?
6.
6 decimal places.
6 decimal places, correct. Then significant figures?
3 significant figures.
How many?
3.
Yes, this is 3. And for significant figures, I'm using red. This is 3 significant figures, like that. So, hey, Esther, you want to say something? Now, there are so many answers in the chat, but surprisingly, the majority of them are correct. Esther, you had something? Now, someone is asking how. That's why I said you must concentrate so much. And we're going to leave here when we have all understood what the significant figures mean. Because if you don't understand this, then we may have not learned. Esther, what is that?
Okay, I think I want to answer the person who is asking how.
Yes.
We know very well that the decimal places are the ones which are after the decimal, and we've counted that there are 6. But when it comes to significant figures, this is what I've thought of. The zeros before a counting number are not considered significant figures, but the ones after the counting number are significant figures. That is it I had.
Okay, thank you, Esther. At least she has said something, though not accurate. That's why I kept quiet here. I don't want to spoil it. I want to write for you something here, Esther. 0 point. But we are going to learn all this. I'm just trying to provoke your thinking. 0.25.10 here. Now, someone put up the hand to tell us how many decimal places are here. And Esther, you must be among them because Patricia, tell us.
Okay, 2 decimal places.
2 decimal places and significant figures.
There are 2.
2 significant figures. No.
Why?
At least for decimal places is correct. Let's leave it there, Patricia. The 2 decimal places are correct, but the significant figures here are not 2. There are 5.
4.
We are going to talk about it.
There are 5 significant figures.
There are 5
significant figures.
Yes, these are 5 significant figures. Yes. So 5 significant figures is correct. And not 2. She had said 2. I think she said 1, which is wrong. I'm going to talk about significant figures, and that is why I said you need to understand this. Kindly, let's have all our hands down. There is a person, Eric. Eric, what is that? This other person, I don't know the name. iPhone. Eh? iPhone, make sure you rename your device such that we call you by name. Eric, what is it?
So I was requesting that you rewrite that number where we had the 5 significant figures. Like I'm recalling some explanation that our physics teacher gave us. Eh?
The one that was 0.025, like this.
Yeah, that one. Okay, me what I remember, like our physics teacher said that a 0 which is before before a counting number, before the decimal point is a significant figure, and that after a counting number is a significant figure, but a 0 followed by zeros before a counting number, they are not significant figures.
And I didn't speak that first place. Eh? Well, you were recalling. Eh? We gave you a chance to
recalling.
Hey, you were recalling, okay? But at least now that one is fair. It really brings out the concept of significant figures. I want you to understand significant figures. That's why I'm going to go a little bit slow. Now, significant figures are the most important numbers on for any given value that you have written. And in most cases, significant figures are used so much in physics. And you're going to find it in this chapter that you're going to study. For those who have not studied indices, you're going to find it. And I'm going to give it really a lot of time. If you don't have enough power, make sure you get a source of power until we get here. And there is a big exercise behind for you that it will help you to appreciate significant figures. So for you to understand significant figures, we are going to start by talking about the rules. Now, to those who have never heard about significant figures, yes, significant figures, they're not different. Let's just keep calm and Yes, all are significant figures. Yes, Jennifer, that is correct. All of them were significant figures, and I will explain why. So let's settle. And I'm going to check if people are concentrating here by requesting everyone to put up the hand, the Zoom hand. Don't start putting your hands up from that side. I don't see. I'm going to put up my two hands. I'm using a laptop, and I'm also using my phone. I don't know how to put up the hand using the laptop. Hey. Where they get the hand. Reactions are here. 16 people are putting up the hand. Hey. Now we are many who can't put. Now all my devices, my hands are up. We have 60 participants. I expect 60 hands up here. 14 for now. Hey, people can't put up the hand. 14, 27. Let me now look for those hands that are not up. These ones are not here. We just remove them. I'm starting with down people. Person having TechnoSpark 7 out. Remove. Someone help me. Those co-hosts. Let me see. Elisa M out. And when I remove you, you may not come back. Vivian out. Techno come on. Out. Let's do that very fast. You may not come back. Who else here? We are now 54. Hey, 40 hands are up. Vivian.
So maybe some of them don't know how to put up their hands.
But they are not speaking. At least the microphones are open, but they are not speaking.
They may be shy.
Zeros.
Put up the hand.
Zeros after after a whole number are significant figures.
Hey. Vivian is trying
zeros
to
after a whole number.
Hey.
Zeros after the decimal point are significant figures.
Hey. Okay, that is Vivian. I was just trying to see if people can put up the hand. I didn't say that you give the right answer. Not that these ones putting up the answer know anything here. Maybe I can even sample one here. These people they're just putting up the hand. I just wanted to see if you can put up the hand. You don't necessarily need to be telling us something. So 35 for now. At some point saw 40. These ones are just stubborn. Yeah, anyway, we can now put down our hands. I wanted to just see. Teacher, do significant figures have types? No. Teacher, you make, okay. Scientific quantities. Anyway, we are going to see what all this means. Physics explained that significant figures are digits that carry meaning, contributing to the measure of the resolution. It's the same, Nina. It's the same. The same in math, it has the same explanation, just that I don't want to define significant figures here because you're going to study it in physics more. So I want to give you the first rule when you're writing significant figures. Get somewhere and write. This is very important. The first rule, teacher, how do you, there is this, teacher, how do you put your hand up? Hey, you could be right. Some people we removed them. Maybe they did not put the hands up. Hey. Yeah. How do you put the hand up? Jennifer Priscilla doesn't know how to put the hand up. Someone should help her put up the hand and explain. Anyway, we are getting that. We don't have to explain that for now. So I'm going to talk about significant figures. The first rule when you're writing significant figure is this: all the values that are non-zero are significant. That is very important. You better write it down. For example, if you wrote any number like that, 211.8, there is no zero here. All of these are significant, and this becomes 4 significant figures. I don't know if that makes sense. Sarah, your hand has remained up. Sarah, you better put. Priska, your hand is up. Okay, the hands are now down. So, any number that you see and it is a non-zero is always significant. It doesn't matter whether there is a point or there is no point. For example, I'm going to test and see if people can see number of significant figures here. 1, 6, 6, 0, like that. How many significant figures are these?
4.
Yeah.
There are 3.
These are 3, correct. 3 significant figures. The person had already seen 4. We are saying all non-zero digits. So if it is a 0, you first hold it on, never first rush with it. Maybe 5, 1, 2, 7. How many significant figures are these?
4.
These are 4. Yes, 4 significant figures. And probably you may have another one. I want to just add this board. You may have another one. Now let's make sure we understand these significant figures or not your crush. 6, 1, 7, 1, 1, 5.5, like this. How many significant figures are here?
7.
7.
Yes, 7 significant figures. Now, that is the first concept. It's the first rule you must understand when it comes to significant figures. Even if they woke you up from sleep, tell them every non-zero digit is always a significant figure. That one you cram if you cannot understand it. So that is the first one. The second one is here. That is the first one. Can you write it down? Very, very important. The second one is here. All zeros that are found between non-zero digits are significant. All zeros, now listen, zeros are not significant. It's what this is meaning. But any zero that you see in between non-zero digits is a significant figure. For example, this number 220,007 is having 5 significant figures. So the zeros are not supposed to be significant figures, not until they are found in between 2 non-zero digits. For example, I will put an example here. For example, you might have something like this, 201. How many significant figures are these?
3.
3.
Yes, 3 significant figures. 2, 0, 0. How many figures?
It's 1.
1.
3.
How many significant figures are these?
1.
1.
I received a call that removed me out. I didn't hear, but people made mistakes here.
1.
These are significant figures.
1 according to rule 1.
1
Okay,
according to rule
1.
According to rule 2.
1.
According to rule 2 or rule 1, I don't know.
According to rule. According to both rules.
According to both. 2009. I know most of you are born in that year. How many significant figures are here?
4.
Yes, 4.
4.
And like that. So I want you to understand the first rule and second rule very well. If it is a non-zero, just count. If it is a 0, now can we close our microphones? If it's a non-zero, if it's a 0 and you want it to be significant, then it must be in between two non-zero values. These are normal basics that we know. Now, this one seems simple as well. Let's bring the third rule. I will assume you're writing that. The third rule is here, and the third one is here. Can someone read for us this? I want to hear some people read. Your hands up. Ferista, for the first time. I've not heard her. Ferista, you can go on.
Significant rule number 3. Leading zeros in brackets to the left of the first non-zero digit are significant. A value such as 0.0085, for example, has two significant figures because the zeros before the 8 are placeholders and are not significant.
And your background is very good. It seems to be too much on that side, or maybe someone else was bringing the noise. So if you have a leading 0 to the left of the first non-zero digit, that one is not significant. So, for example, this one has only two significant figures because the zeros are to the left of this number. For example, we may have, now this one may confuse a little bit, but I pray that you get it as well. We may have this. This is how many significant figures?
2.
Yes, these are two significant. These are two significant figures. And 0.001, like this. How many significant figures are these?
1.
This is significant.
It's 1.
Yes, this is one significant figure, correct? So it is very important for you to start knowing that a 0 is not a significant figure, not until it is between. Now this is 0.0085. How many?
2.
Calculator.
2.
Significant figures.
2.
How many significant figures are these?
There are 2.
2 significant figures.
Significant figures like that. So get rule number 1, get rule number 2, and get rule number 3. Join them together and you will not regret. Rule number 3 looks like that. I want to bring, now the one I'm going to bring is the most confusing one. I will assume that you know that it confuses and you give it a lot of time to read it. And I'm going to read it. Naomi wants to read for us. You can go on. Naomi, you can go on.
Trailing zeros for a whole number that ends with a decimal point are significant.
Naomi, you can go on.
For example, a value written as 320
shows the decimal point, which indicates that the 0 to the right of the 2 was measured. Therefore, the value has a total of 3 significant figures. If the decimal point was not treated, then 320 would have only 2 significant figures. In general, any confusion this may cause can be avoided by writing values such as these in scientific notation.
Yeah, you broke a little, but then you've read it very well. Now, this one confuses a little bit. Now, I am going to emphasize something here. I would assume you're listening. All zeros are not significant figures, whether they are starting or ending, not until it meets the following conditions. 1, the first condition for a 0 to be a significant figure. Now I'm going to close everyone's microphone here because we can't continue with this. Now my co-hosts, because we are already late and everyone is tired, we don't have to keep. So let's not make noise because people here are now sacrificing. We're already out of time. So those who are here want to learn something, you can't keep making for them noise. I had to close everyone's microphone because of that. Now, all zeros are not significant, whether you find it where or not. But a 0 is only significant if it meets the following conditions. The first condition is that if that 0 is in between 2 non-zero digits, you count it as a significant figure. The second condition is that if that 0 is before a non-zero number, but they have put a decimal point, this number 4, they are saying you count a 0 to be significant. I don't know how you will summarize that, but you can only count it to be significant if, for example, if it is 3, 2, like that, and there is a dot here, this 0 becomes significant. If there is no dot, then this one can never be a significant number. For example, I'm going to put here 4, 0, 10, 0, 10, like that, 5, 0, 0. Point. Let's type in the chat how many significant numbers are there. For that one, can I see? It is 4, 0, 1, 0, 5, 0, 0 point. Yes, people have 7, correct. These are 7 significant figures. If I removed this point, then it would not become. If I remove this point, if I remove the point, then it will become 5 significant figures. I want us to correct that. I'm going to write the same, but I removed the decimal place. 4, 0, 1, 0, 5, 0, 0. Those are not now 7, but they are 5. Eric has already given us 5. And maybe some other people can see that. So this is very important, and it is the second last principle if you can only master that. For example, another one can be, now let's not write. Can we look at this and give me the answer? Let me even write it in black. 20 0.5. 1 has how many significant figures? As someone is requesting for the second rule, I'm going to display it once again. How many significant figures are there? iPhone has 4. Yes, 4. Now people have mastered this. Did I really teach significant figures if people are giving? Hey, I thought I'm here to explain that. Oh God. Okay. Someone is requesting that he did not take the second rule. I'm going to post this such that we get to get that rule. But maybe let me just take it back a little. You take a screenshot. Rule number 2. Someone was requesting for rule number 2. It's over there. Just take a screenshot and we proceed. Then we'll proceed to rule number 4, which is here. Provided you see a decimal point, that number becomes significant. That 0 becomes significant. Now, this one is the other funny one. Rule number 5. Very, very stubborn. And someone read for us that. Now, this one is too stubborn. If you cannot see that, then you may not. I want to call some new hands. Let's keep putting up the hand. Bridget, can you read for us? Bridget, you will unmute and speak to us.
Trailing zeros to the right of the decimal place are significant. This means a value such as 12.000 has a total of 5 significant figures. Since the zeros after the decimal place have been measured to be zeros, indicating they are as significant as any other non-zero digit.
Okay. Thank you, Bridget. And this one means that every time you see a decimal place, the zeros on the right, the ones they call trailing means those that are hanging. Those zeros you see to the left, this one is right actually. That's right or left? Those zeros become significant. To the right of the decimal place, they become significant. And this is the very last rule. And I'm going to demonstrate here. We have so many examples. I'm going to display the examples for you to understand how to work with significant figures. I'm going to display here something like this. Maybe let me put it even up to down. So, 12.000. These are all significant figures because the zeros are coming after a decimal place. This one has how many significant figures? Let's use the chart. Can even copy directly. Let's use the chart. This is 5, correct? 5 significant figures like that. Okay, that is enough. Don't try it again. How about this? Are those zeros trading or no? Now, someone has a question here. I'm going to flash it here such that we all get the answers. Get ready to write for me this answer. Get ready to write for me this answer. Someone is saying 10. I don't know why you have 10 there. So I'm going to put another question here. Can you get ready to the chat to give me the answer? The question is 75.500. How many significant figures are those? Hey, Davinia has 5. Shannon has 5. Now Eric has 3. Hey, 3 is coming up. 5 is on. 5 and 3. Now who takes this? 5 and 3. 5 and 3. We have 5 and 3. 5 and 3. Are we not going to vote? 5 and 3. Mukisa insists is 3. Faith Hilda says it is 3. iPhone 5. Jennifer Priscilla 3. Hey, Joyce 3. Naomi 5. Bridget 5. Joyce 5. Jemima Jaden 3. Erica, if that is how they pronounce that name, 5. Macrin 3. Isaac 3. Davinix, this is 3. Esther Agatha 5. Yeah, now 5 and 3. Let me see. 3 for Vivian. Sabrina 5. Joseph 3. Esther. Hey, now let's just vote. If you're sure your answer is 5, your hand up. Let's just use the hands. 4 hands. 5, 7. If you're sure the answer is 5, your hand up. I'm going to vote from here. 5, your hands up. 5 has how many hands? And I'm knowing people who are putting up the hands. Esther, Agatha, Michelle, Shannon, Sabrina. They are reducing or what? Let your hands be up. Naomi, 15, 16. 16 hands up. 17. I don't want to approximate the hands because these are human beings. Okay, 17. Can we put all those hands down? I'm going to lower them from this side.
So there were 18.
No, there were 17 by the time I counted. Okay, 18, Kadi. Let's have those hands down. If you're sure the answer is 3, now I want to see these people. How many are we? 7, 8, 9, 10, 12, 13, 14, and no draws here. 15. 14 now. The one person has dropped. Let me see. I had mastered some of these hands. Maybe people 15, 14. It's fluctuating around 15, 14. And the final answer is 13. There are 14 hands. Can we put those hands straight? These are 14 hands. So you realize that the 14 hands did not, okay, maybe someone can tell us why 14 is correct before we bring in another person to talk about 18. We are getting that, don't take a lot of time. I'm picking Isaac. Isaac, can you go on? Isaac, I've requested you to open the microphone. Isaac, Elijah, if Isaac is not ready. Okay, Isaac, you can go on. Oh, sorry, Isaac, we can't hear you. Sorry about that, you're not clear. Vivian, maybe give us that reason. Why is 3 not 5?
Me, I'm using rule 2.
Rule 2?
Yeah, all zeros that are found between non-zero digits are significant, and it's not between any non-zero digits, so they are 3.
Okay. Vivian has an idea, though the right one. So maybe I've now got the reason as to why people are confusing, but the correct answer is 5 significant figures. 5 significant figures. Because of time, we may not give points for people to explain because of time. Can we close people's microphones? Yes, the answer is 5 significant figures. You can't. The reason is that the zeros are coming after the decimal point. Those zeros become significant. Whether there are 10 or 20 of them, they become significant figures. Now, if you were doubting that, just take it because of time. And I'm going to put here one question to see if people have now appreciated that. 2, 0.10. How many significant figures are here? Put that in the chat. I pray that there are no errors here. Let's put it in the chat. How many significant figures? Yes, I have not seen any errors. Maybe to mention a few names. Shannon, 4, Davinix, 4, Abel, 4, Eric, Michelle, Bridget, all those are giving us 4. IVY, 4, Ario, Estin, 4, Trina, 4, Joyce, 4, Esther Agatha, 4. There's a person called Yusuf, but there are now many. Elijah, 4. What if there is 1 0 before that number is significant? Okay. We'll also see that in the summary here. We're going to see that in the summary. Can someone prepare to read this summary? Put up your hand and read for us that summary. Let your hand be up before I display the summary. The summary is here, and someone can read for us that summary. I've not heard from Dorothy. Dorothy, you can go on. Nakiguli. Dorothy.
Trailing zeros. Trailing zeros. Okay.
Okay, Dorothy seems to have gone off. We don't have time, unfortunately. Can I pick a person? I'm sure she can speak here. Patricia can go on.
Trailing zeros, those at the end, are significant only if the number contains a decimal point. Otherwise, they are insignificant. They don't count. 5.840 has 4 significant figures. This 120,000 has 6 significant figures, and then 120,000 has 2 significant figures unless you're given additional information in the problem.
Correct. And that is the biggest summary we can make here. It is the best you can write for now. Just write that summary down. It will summarize all your errors. Allow me display 1 or 2 examples here and we go away. So take that screenshot quickly and the examples are here. This 10082, this is read as 10,082, is having 5 significant figures because these 2 zeros are in between 1 and 8. That one, I think by now, let me even open people's microphones, but don't make it. Don't make a lot of noise, but at least when you hear something that is not familiar, you mention it very fast, we correct it straight away. This is 70,000, and that one has only 1 significant figure because there is no decimal here. Then we have 0.0025. This one are not significant. These are not significant because the zeros after the decimal places only count if, now I don't know how to even explain this. We had talked about this in I think rule number, I'm not remembering that, but the zeros to the left are not significant. I want you to remember that rule.
Number 3.
Rule number 3. Yes, rule number 3. if you remember that very well. So it says leading zeros, the left of the first non-zero digit. All those leading zeros are not significant. The leading zeros are not significant. If you cannot understand that, make sure you put that screenshot, it will help you. When it comes these are two significant figures because these two are just leading zeros. Are not correct zeros. But if these zeros were here, they would be significant. But because they are not there, they are not significant. So when it comes to this, these are three significant figures because of this. These ones are useless. Then when it comes to this, now here, you need to be very careful. Here, all of them become significant. All of them become significant. And I don't remember that rule, but it said something. Whenever there is a point, it is significant.
The last rule.
The last rule, yes. So this zero is significant. You remember where we wrote 3? Provided there is that dot, the zero becomes a significant. That's why we are having this 10 read as, you see this zero around here is becoming significant because of that decimal, and this 3 obviously become significant. Then for the last one is to 5 significant figures because we can't count these 2. We only count these ones here. So I will assume that one makes some sense and it will help you going forward. Then I want to give you a quick self-checking test here, and it is here. I'm going to start by someone put up the hand and tell us this first one. How many significant figures are here? Yes, Michelle. This person using iPhone, I can't pronounce your name. Michelle? These are 2. Yes, 2 significant figures. Then Ebo, you can tell us the next one. How many significant figures are here? 4 significant figures, correct?
4.
Yes, correct.
4. Wait.
Yes, correct. Then the next one, how many significant figures?
2.
How many significant figures are here?
2.
Yes, 2 significant figures. Someone is saying 3. And then here, how many significant figures?
3.
Yes, we have significant figures.
3.
Next one is here, a quick one. We may put down our hands and just mention. How many significant figures are here?
5.
5.
How many
5
significant
significant.
5.
figures? Now, if it is a whole number, if it is 0.070, this one is not counted, but
There are 2 significant figures.
So these are 5 significant figures. I don't want to explain. Then this one is how many significant figures?
4.
4 significant figures. Yes, correct. Then here, how many significant figures are here?
6.
6.
6.
Who typed the answer in the chat? I want to read the names of people.
6.
5.
Tell me the number of significant figures here. Let's write it in the chat.
5.
It's 5.
5.
I had
Sir, it's 5.
I had 6. I want to say 6. Anyway, here there are five significant figures, correct. Then
Just 3.
Oh no. 3. 3.
Let's write this.
3.
This one, 2.
Yeah, 3.
We are going to see 3 to 9 and 10 power 3 is written as 3, 9, 3, 9, 3, 2, 9, 0. I think it doesn't have this other 0.
Yeah.
It's written like that. So how many significant figures here?
3. Come on.
3 significant figures.
3.
Let's check and see.
That there are 3.
Yes, these are 3 significant figures. How many significant figures are here?
Oh. 2.
How many?
2 significant figures. 2.
These are 2 significant figures. Then here?
Significant figures.
2 significant figures.
How many?
2.
2 significant figures. Correct. So, want to here with that exercise. Let's get that exercise down. Let's get it back such that you answer that in our books. You will post the answer on WhatsApp. I'm going to also send this exercise on WhatsApp.
Excuse me.
Now, the person who was speaking, can you speak again such that put your hand up. Yes, Patricia?
Okay, so then the exercise is not that clear on my screen. The digits are so small.
You're using a phone or a laptop? Patricia? Patricia, using a phone or a laptop?
A phone.
For a phone, you zoom. You pinch as if you're zooming a picture. It will be visible. Have you tried that? Let me know if you can now see them.
I can.
Okay. Just use your finger and try to pinch in such that you're able to. Zoom allows you to pinch in and see that correctly. IVY, your hand is up. May I know why? We are late. IVY?
I'm using a laptop.
For a laptop, I really don't know where you can go, but you're supposed to go to, are you seeing where you leave your microphone open? I talk to you, I help you. Are you able to hear me?
Yes.
Yes, you go to where they have said, where, let me see, but there is somewhere you can zoom in from. Let me see. I'm also going to send it to WhatsApp. I can't see where to.
Sir, I've got it.
You've got it, eh? There is somewhere to do with size resolution. Okay, make sure you're able to see. Then any other person with the challenge? Hey, people are saying bye here. The screen is not clear. Yeah, for those who had issues with the screen, make sure you're able to see. I want to end the lesson here. I want to, of course, wish you a good day for those who are going to. I wanted to end the lesson here because of time, and I will request that you go through those rules very well. Each rule you read, you give yourself an example. Each rule you read, you give yourself an example until you master them. When they introduce these significant figures in your school, help the students understand them. And when you go for physics practicals, they will tell you to write to a certain number of significant figures. Is this correct? I've seen something in the chat. Is this correct? So 0 is significant if it's between non-zeros, comma, if there is a decimal. Yes, someone has tried to summarize it here. Faith Hilda, you better just put up for us the hand and you summarize for us here. Someone has tried to understand this very well. Put up your hand and help us read through such that your friends can get it as well. Hilda, are you able to? Hilda, can you read for us that summary such that your friends can write it down?
So a 0 is significant if it is between non-zeros, if there is a decimal point after the 0, and if trailing after a decimal point.
Yeah, so a 0 is always not significant, not until it makes those conditions. Make sure you write them down. You can also summarize your own such that it helps you. Thank you for being here. We've gone past time, but we needed it. Can I get someone to give us a closing prayer? And we leave it here. I'm going to open all people's microphones for now, such that it is easier for us to get a closing prayer. Can I get someone to give us a closing prayer? Faith, are you giving us? I've not heard from Sarah Namtebi. Sarah Namtebi, you can give us the closing prayer.
Joyly.
Sarah Namtebi.
Please have yourselves for that prayer. Thank you, Lord, we thank you, Lord, for this wonderful lesson for today. And we pray that we have learned a lot from what they have taught us and we understand them. And we pray that we also success in what we are going to learn.
What is that?
Okay, we lost our towards the end, but thank you so much for that prayer.
Amen.
The lesson.
Bye-bye.